from outer space. Actually, it came from Slack. This is Julian's proposal. He is KF4MOT. He has a proposal for 5 gigahertz RF. The link to his proposal is in the show notes. Go ahead, check it out, download it, and look at it. Julian's intent here is to take the output of any SDR, ranging from -10 dBm HackRF up to the +10 dBm EDIS B200, run it through an appropriate attenuator network for levelization, and create a filtered and amplified output at the 20 dBm level to further drive another board to 40 dBm. He suspects that choosing a correct attenuator value will be important, since overdriving the amplifier will create harmonics. And that second harmonic is the one we really need to avoid. The signal path is SMA input to an amp, to a filter, to an amp, to a filter, to an amp, to an SMA output. The substrate is 62 mil FR4. The wildly varying dielectric constant, horrors, shouldn't matter, since both filters are tunable, and the estimated 0.5 dB per inch loss in the substrate should be more than made up for with all the gain on this board. None of the other elements on this board are critical. He has some ideas for filter tuning to make it easy for those without fancy test equipment, and he considers that critical to the success of the project. The SDR could be used either as a signal source or as a receiver with appropriate attenuators. He wants to test this out before publishing a recommended method, but he plans to try a cheap 8 GHz power meter and a noise source in combination with the SDR as either a signal source or spectrum analyzer to see if he can come up with a good, consistent method. A simple power out indicator was included on the board. It just lights the LED when the output hits the roughly 20 dBm level. It could be made more complex or informative in a future board revision if testing and use deems it a useful thing. Board dimensions are roughly 2 by 4 inches. It was not made to fit any particular enclosure, but instead is sized to fit the limitations of a low-cost board house. Julian's intent is that this board could be mounted close to the SDR, while the big PA could be mounted close to the feed horn to minimize feed line losses. That's not set in stone. Probably any combination of positioning should work so long as feed line losses are accounted for. He would like to take a couple more days to compare the schematic to the Gerbers, since according to Julian, Upverter, which is the editing software he is using, allowed him to make some pretty serious mistakes without any errors or warnings. After that process of looking it over and checking it over, and any feedback that we have for him, if there are no comments or complaints or suggestions, then he's going to go ahead and place the order. He's thinking a quantity of about 20 since the price won't be any lower for a lesser volume. It should take a couple of weeks to get them. You can't see the 3/4 inch pipe cap filters that are soldered to the bottom layer, but Julian promises that they are there. So what we need from you all that are listening to this, we need recommendations for a board house that does RF substrates. He's been planning to send an email to his normal board house, a TechNet, but he hasn't gotten around to it as of this recording. He's leaning to using Rogers 4350, but he's open to others. Really, any substrate with consistent E sub R that doesn't cost an arm and a leg. So please review this design. Give feedback on the filter tuning, on the dimensions, the assumptions, the board house recommendations, and anything else that you see that would improve this part of the project. And beware the Ides of March.